That's why our base is important. Okay. I will talk about it, but don't worry about it if sum is not introduced. Okay. We can use tan h again, but we need to solve the condition. But for now, in the simplest case, we use sigmoid. Okay. Tan h we will use, but not now. That's why our base is important. Okay. Sigmoid. I will talk about it, but don't worry about it. So once we update the weights or parameters, guys, what are weights and parameters? Whenever I say m, whenever I say beta, these are nothing but m and b. These are all what? Learnable parameters. This is why we use machine learning, right? To learn the components of the formula, that is nothing but m and b. Is everyone clear? Guys, I'm not going to repeat this part. Whenever I say weights, parameters in terms of model, I always means this learnable parameters. It can be m, it can be any value you want. Are we clear? Is everyone clear? And guys, once we update the weights and parameters, then what we do? We check what is our current loss. Do we need to go more? So I'm going to write, this is just for us to print in the Python to know whether loss is decreasing or not. Calculate final loss using loss slash cost function and iterate until satisfied. Or we will say the sixth step, we are done. So this is what logistic regression is, end to end. Are we clear? Jonas, it is not that short. Finding M and B is machine learning, but how we perform learning, this whole operation is called as machine learning. This whole operations helps us find the optimal value of parameters, and parameters help us find that formula which will fit our features. Okay, that whole process is called as machine learning, Jonas. Okay, are we clear, Jonas? Yeah, great. Is everyone able to understand what logistic regression is? I'm asking everyone. Guys, are we clear? Done. So now I will start the practical. Okay. We are also going to have alpha like something here. What about L1 and L2? Guys, L1 and L2 was what? It's a kind of regularization. Regularization, we can also do it here. But in the loss function, what we are getting, regularization we will do at what step? Guys, regularization we will do at what step? After final results? Model parameter tuning. See, in the loss function where we are using, we can still add those parameters of N1 and N2, and it will keep again the values at lost. We will use it in the cost function part. Okay, we will use it in the cost function while adding in the cost function, because the parameters of beta which we are finding is again present in this area. And when we are trying to reduce the overall cost, it will, if the values of those m and beta are small, that will also help us do the regularization effect. If this part is also clear, it will also help us here. Sigmoid is nothing but, guys, in sigmoid there are no parameters of m and b, so it will not help in sigmoid. Sigmoid is just like a function. You will give something, it will output something. That's all. Where we are changing something, our values are constantly learning in the linear equation part. So loss function we will apply on cost function, and it will impact the linear equation part. Are we clear? This is nothing but our learnable part. Yes. This is what is going to differentiate those two classes in 0 and 1. And that's what we are going to do. Okay. We need to find a way. See this. If we have features like this, we need to find a way. Let's suppose this is tall. This is tall. This is short. Okay. We need to find a way such that tall values, when we get into the Z, tall values, when we get into the sigmoid, should be greater than tall values when we calculate with y equals to mx plus c. This y value should be greater than 0.5. Then only in sigmoid we will get 1. Yes or no? So our m and beta values should be optimized in such a way for all the tall values, the y value should be greater than 0.5 till infinity. In short, it should be greater than 0.5 all the way till minus infinity. That is what our m and other parameters is going to be trained on. Only then our sigmoid will be able to differentiate this one as 1, this one as 0. Yes or no? Makes sense? So the parameters are going to be optimized for sigmoid output because that is what our cost function is. Make sense? Others? Guys, now you need to wrap your mind on this one, okay? Everything is mathematics. I'm just saying in terms of that. Okay, I think very few people understood that. Okay, let's go to the important part, the implementation. Guys, maths is fun. Now, because this is the first batch, you guys are learning it for the very first time. Again, in the iteration, in like few months, few years, we are going to again revise all of this concept, or you might never go to machine learning, okay, because of this agentic and others. We don't know, but we should be able to do everything. When you go to that part, you might again revise the mathematics, then you will feel, wow, this math was doing all of this internally. Then you will love mathematics, not now. Yes, correct, Alok. Okay. So now let me talk about the implementation. Let me create the file name as logistic regression. How many of you were able to do the assignments? I've given the assignment, right? Guys, how many of you were able to do that? This week confirm? Okay. Yes, not me. Guys, it was very simple assignment using pickle and few other things. Okay, I will also give assignment, okay, today. So let me talk about the data set which we are going to use. Again, a very simple data set. So guys, this is a diabetes data set. Everyone might have heard, whoever is watching the tutorials of machine learning. And let's talk about the data card. Okay. And guys, this is just a nomenclature which we use in machine learning world. If you join a startup, they might ask you about data card. Okay. Data card is nothing but a terminology which you use to put information about the data set. Are we clear? Okay. Again, something out of the topic, but it is very important for you as an AI engineer. It will help you. Okay. You will become a fancy AI engineer if you know all of these terms. So out of context. When someone talks about data card, it means it should contain information about the data. Info about data. Here we will mention data sources. Okay, what are the sources we collected the data from? Information about the data. How many rows of data we have? How many rows and columns of data that we have? Features, information about the features. No, Baiju, we should not say directly just like a metadata. It's very different. I will talk about it, okay? Here we will have features And also information about features. Information like what is the range of each column. And just give you an example. You can omit whatever you want, but the data card main point of that is to understand more about the data. Okay. Range of each feature, its type, its type. Also, we will write something like, is this data having some kind of missing values? If yes, this is about raw data. When you download some data, this is what you're going to get. Okay. And a lot more other information. So what someone is going to do, you as a machine learning engineer, is going to ask your manager that now I'm starting on a project. Now I am starting on a project and I require some data. Your manager is going to give you link of the data. It can be in Amazon S3 bucket, on any other closed source, private data. Your manager is going to give you link of the data. Below this link, some people might create, but a company who is well established and has all of this information, they usually have this data card as well. So they will, in this link, you will find this data card in a txt file or a readme.md file. It can be in any other format. It will provide us all the information about the data. So you will read this, you as a machine learning engineer will read this, and you will understand directly that this is the raw data. Now you will target that I will read this data. This file has maybe 5 different CSV files. It has missing values. It has this features and other things. Are we clear? So it is just to, because we will not have Kaggle. The private sources guys will not have Kaggle link, just like this one. When your data is closed source, it also needs to have some kind of information like this. Yes or no? Everyone, are we able to understand about the data just by looking at this page? Everyone? Yes, we are able to understand. So we as an ML engineer, if we are the one collecting data, we also have to create something like this. Okay. This is about data card. And this is very rare, but some companies do it. And I personally like it. This is called as model card. Model card contains information about model performance, link of test set where on which link of test set on which evaluation has been done, on which we did evaluation. Okay. And some other things like whether this is from sklearn. Okay. What is the confusion matrix performance? So people who is going to download that job file, just for an example, suppose I send you job file, only job file. Do you know anything about this model? Do you know anything about this file? In the previous class, we were saving the model as job lib, yes or no? Guys, are you sleeping? Do you don't want to learn all of this? I will directly go to the point. If I only give you .joblib, do you know the performance and any other information? What is the test set and others? No. And if you have some kind of a file like a txt where you have all of this information written, will you be able to pick work fast? Yes or no? You will be able to pick work fast, which data set it was tested on, when this model was created date. So you know all the information. So information about model is called as model card. Information about data is called as data card. Are we clear? Are we clear? Okay. Now, one last thing is artifact. Yes, Anderson, we usually create README only, but a lot of people right now don't know about README. So as I mentioned, it can be an MD file, it can be any other file. Okay. There is something called as artifacts. Now, artifacts, we can say files. Artifacts are nothing but files. And artifacts is always relevant to something. Okay. It is relative to something. When I talk about model card, what are the artifacts of this model card? What are the artifacts of this model card? all the PNG images which I'm using for the model performance. Yes. If I talk about confusion matrix is the image. Yes. Confusion matrix is my is my artifact for the model card. Other things are not artifact, guys. Other things are just information. But artifact is the raw source of data which we use uh, for a particular file. Now, if I talk about artifacts for our production IPYNB file or .py file, I'm creating a .py file for linear regression. I have given this assignment, yes or no? Linear regression, create a .py file. So what are the artifacts of this py file? What are the things which we require to run this linear regression? We require a model. We also require preprocessor. Those are two different files. Pre-processing contains all the scaling. Those are both job lib. Those are both job lib. So these are two artifacts which we require to run this file. Guys, encoder is also in preprocessor here. Is everyone clear what is the artifact? It is always relative to the main task. It means something which we require to run something or different parts of something. Model card is not just information. It is also uses confusion matrix. But to create a model card, we require confusion matrix. So confusion matrix is nothing but the artifact of it. So there is no single meaning of artifact, but it is pretty clear that artifacts are files which we use it for something. Okay. Are we clear on artifact, guys? Yes. Okay. Just giving you what we do in actual organization. Okay. Not everything is about machine learning. If your managers, if you did this small part, okay, if your manager asks you to train a machine learning model and you also provided a model card, your manager and company will be very happy. Then you are putting a lot of this detail into it. Okay. So where were we? Sometimes I talk a lot. Context. This dataset is originally from National Institute of Diabetes and other things. It contains, in particular, all patients here are females, at least 21 years of old of PIMA Indian heritage. So this particular thing contains several constraints were placed on the selection of these instances from a larger database. I think we need to read it. The objective is to predict based on diagnostic measures whether a patient has diabetes. This is the objective, everyone. Okay, is to predict whether a patient has diabetes, and all patients here are females at least 21 years of old. It contains few features: pregnancies, number of times pregnant, their glucose levels, and when the glucose level was taken, 2 hours in an oral glucose tolerance test and other things, whatever it is. Blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and output, whether they have diabetes or not. This is the data that we have. This is a cool data set, right? Everyone, are we clear on the data set? So these are our X columns. These are our Y. All right. This is about data set. So I've already downloaded this data set. So let me bring it up. Okay. Let me close this. We don't need it. Just wait. Okay. Ah. This is the data set, diabetes.csv. You guys can real life or artificial. Guys, this is the real life data set. X means features. Yes. X1, X2, X3. Okay. If you want, I can also show it like this. See this all outcome. All outcome are either 0 or 1. Age is, we have starting from 21 all the way till 81. So a lot of factors we have here. Pregnancy starting from 0 all the way till 17. So using this filters, it is very easy to do it. Okay. You guys want link? I will share the link. Don't worry. So now let's get started. Let's start with the markdown. This is the data set. It will ask me, not even ask me to select a kernel. How many of you are still not familiar with the scripting part? Guys, this is notebook. Don't get familiar with notebook too much. We don't use notebook. We only use notebook for experimentation. How many of you are good with scripting now? .py. How many of you are able to do it easily? Lalit is able to do that. Vatsla, Mohit, Ashish, Dipanshu, Akshat, everyone. I'm not. Guys, if you are a data scientist who only knows IPYNB, trust me, the journey is going to be very, very, very hard once you get a job. Okay. Without it, we never use IPYNB for production. Never. So please don't skip this part. Else it is only going to create issue for you in future. All right. .py for MLOps. No, Jonas, MLOps is a part. MLOps does not have, MLOps has nothing to do with the deployment. MLOps is the whole thing which we do for the coding part, iterating over it. That is MLOps. But we should not directly say deployment as MLOps. Okay. There is no much difference between Pankaj. There is no much difference, but about creating modulars and other coding is different. Now here, everything we create in a single file. But in scripting, we can also do in a single file, but when you try to practice on that, you need to create modules, different packages and other things. Okay, that is the main part. Yes, classes also we can create here, but how we create the main coding structure is what we need to learn always. Okay, now let's focus fast. It's already 9:09. And let me import few libraries and read the data. pd.read CSV. Next thing is we are going to use df.head as always to see how our data looks like. It looks correct. Pregnancies, outcome 0101, exactly what we were able to see in Kaggle. Then df.info. Okay. Do we have any null values? 768 entries. We don't have any null values. That's great for us. Okay. We will check the shape. Shape is going to be 768, that is same, and with total number of 9 columns. Okay. Now, what are the columns we have? We can just use df.columns and see these are the columns. Okay, because column we can use it later. So here I've extracted the column values. Now we will check some basic information, whether something is null values or not. I've already tested it here, but here it is little hard to focus. Non-null, non-null, and this part is very simple. We don't have any null values. All of them are 0, no null values. Then descriptive stats. Let's look at the numerical stats of it. Describe. We have count as 768 in all of them, and we have minimum values. Most of them are starting from 0, but only the age is starting from 21, which is the correct information what we're able to see in Kaggle. We have max. Pregnancies maximum is 17 and age is maximum in 81. We have seen that as well. Yes, correct, Alok. Okay. Outcome is maximum is 1, minimum is 0, and 25 percentile, 50 percentile, 75 percentile is only 1, others are 0. So it is correct. 25 and 50, that is the half 55 is 0 because it is percentile. The later part is 1. Okay, looks good as well. This is just a basic information. Now what I will create X and Y. If I drop the target column, okay, what is the target column, guys? What is the target column? I need to create that target column. Outcome is our target column. This is our outcome. So here I can write target column is nothing but our outcome. And this target column will go here, and I'm going to draw the target column, and only target column I'm going to retain in X and Y. Is this part clear? Okay. And if we check the distribution, just wait. Why did I miss it? Okay, not missed it. If we check the outcome counts, we have 500, 0. We have 261, 268 as 1. Okay. We are just checking the distribution. There is some imbalance, but obviously we will have imbalance. In real world, whatever we want to have as a target, we always see it as less in terms of healthcare also. In general cases, not every patient have diabetes, but few has. So this follows the real world. It is imbalanced data set here, But in real world, this is what balance looks like in terms of healthcare. Yes or no? In real world, we will not have 500 patients, and otherwise the probability of having diabetes is 50%. But here it is not like that. Okay. But this is just a class distribution. We are able to see some imbalance. And guys, do we solve the imbalance in the first iteration or after multiple iteration? When we solve the imbalance, do we solve the imbalance in the original data? After, correct. We solve all of this fancy things, complex things after multiple iteration or in the next iteration, but not in the first one. Okay. If everything is that simple, then ML engineers, data scientists will only have 1 day of job. Create a model, you know everything, just create it. No, we will doing this on iteration. It might take weeks, it might take months also to collect data, feature engineering and others. So it is an iterative process. Okay. Now let's count how many zeros we have in each of them. In pregnancies, how many zeros we have. In glucose, how many zeros we have. In blood pressure, how many zeros we have. Guys, if blood pressure is zero, is this a good thing? If BMI is zero, if insulin is zero, is this a good thing? Pregnancy zero is fine, but other zero is good? No. So let's count. Do we have any values like zero? So in pregnancies, we have 111 zero. Do we need to impute zero? Do we need to remove zero and impute any other values instead of zero in pregnancies? No. In pregnancy, that will be a wrong thing. So guys, always make sure that you understand data. If the value of this particular column is nothing but only P, if you don't know what this feature is, will we be able to decide to not do imputation? No, not possible. We don't even know what this column means. We will be doing imputation on everything. Are we clear where to not do imputation and why it is important to learn features? Everyone? Is everyone clear? Yes. Always remember your data. Otherwise, everyone will be using some function and doing imputation on all. That is very wrong thing to do. Okay. So here we are able to see glucose, blood pressure, skin thickness, and everything is there. So what we can do, we can just sort these values up and check which one has the highest one. So we are able to see insulin is having the highest. I just sorted out, guys. This value using pandas, I just sorted the values in ascending. So highest we are able to see skin thickness, pregnancies. Insulin is having the higher number of zero. Skin thickness is second one. Then blood pressure, then BMI, then glucose. All right. Zero means Pankaj in this particular value for glucose, we are also able to see a value of zero. Let me just show you zero. These are the values where glucose values is zero. Glucose value zero means your body does not even have a single point of glucose. Does this sound good? No. Here, if I select all, and let's say if a person blood pressure is zero, is that person going to survive it? No. So this is an error. Yeah, he died. So this is zero. Okay, it cannot be. So there is some issue. Okay, there is some issue. So now we need to also fix that. But before that, what we can also do is that, just give me a second. Okay, currently we are not doing imputation. But guys, when we need imputation, will we be able to do it? So imputation, I'm not doing right now. Everyone knows how to do imputation. There is a domain knowledge. There is a little bit of domain knowledge. But yes, perform imputation on what is this value? Insulin. This is your assignment. Imputation is very simple. It's up to you guys. You can check multiple model performance. And I think the best way to do is just wait, guys. Okay. We will do one fun exercise for the assignment. Don't worry, I will remove pregnancy and glucose. Remove pregnancies. So your task is, this is for assignment. Your task is to do the imputation and perform imputation separately. If you were able to find that insulin average value, you can do some statistics, whatever you want to do. do some statistics. Either you can use median on all, mode on all, mean on all, whatever you want to do. Do some kind of imputation either separately or all of, or single imputation on all, and try to train a model. And in our community, try to because in the random split I'm going to say, going to mention random state, so everyone is going to have the same test set. Yes, I want performance number what you are able to achieve in the assignment. Okay, it's clear. Everyone will post on the community what is that accuracy metric you are able to get from this assignment. Is everyone clear? Seed, Shiv, random state is seed. When we separate the data, we mention seed, right? So just for fun, let's see who got the higher marks. Shiv, I will mention later. What value you want to use, I will talk about it later. Okay. Let's mention ROC or something others. Yes, Vamsi, you can do that. Guys, whatever imputation technique you want, you can use it. Whatever imputation. In the test set, your model should perform best. So let's see who can create the best model using this imputation techniques and anything others. Okay. So let's focus everyone now. Next thing is correlation. Everyone knows how to create correlation. Correlation. Anderson, I will give break. Okay. Just give me 5 more minutes, then I will give break. Only 5 minutes. This is the correlation matrix. Everyone can read it. What is the correlation? I can see skin thickness is having very less correlation with outcome, skin thickness and blood pressure also. But glucose is having the higher one. Yes. And it sounds pretty like glucose is the direct factor, right? Glucose is directly dependent on your diabetes. So we are able to see a higher marks there. So it is a high correlation. That is about glucose. Now let's directly go to the train test split. Glucose and insulin. Yes. I'm importing train test split and numpy. Everyone see this. I will complete it fast. And I'm using something called as train test split. I'm passing X and Y. Test site, I'm keeping it as 5. Let's not pick 5 because this data set is small. I want to keep it as 90-10 because we don't have a lot of data. Yes or no? We have total values below 900. So I'm keeping 90% in train for now and 10% in test. Are we clear? Random state. See, this is what random state is 42. Everyone will be using 42. That's how you will get the same exact test set. Stratify equals to Y. Stratify Y ensures that your training and test set have the same proportion of sample. Let's say you have, just giving an example. Let's say you have 500. Okay, we already have 500, right? Okay. Let's say we have 500 as zero outcome. Total counts of 0 is 500 and total counts of 1 is 300. If I want to divide it into a test set of 80 to 90 to 10, it should have similar kind of proportion. 90% of 500. Guys, what is 90% of 500? What is 90% of 500? Is 450. 50 is left for, 50 is for test. For this one, 90% of 300. 270. Only 30 is left for so guys, here we are doing splitting based on our Y column, which is nothing but our outcome. So I want to split equally. If I say 90% on train, then 90% of both 0 as well as 1, that is not diabetes and diabetes, 90% of both of those should go to train and 10% of both should go to test. So using this, we will be able to have balance split. Yes or no? If I do random, guys, if I not use stratify, it might be possible that out of this 500, 490 is on train set. Out of this 300, only 100 is on train set. How much is left? Only 10 is left for test set, and only 200, all 200 is left for test set. Is it looking balanced? Does this look balanced or this one is balanced? Tell me. This is case 1. Case 1 with stratify. And this is case 2. Case 2 with random. Case 1 is more desired. I hope everyone is able to understand. So when we mention a stratify, this is what a stratify is going to do. Going to distribute equally based on our column. Our column is 1. Clear? Are we clear? Okay. Last few things. Training a model. We have 384 in train and 384. Again, why it is 384? Did I wrote something else? X train and okay. X train and X shape. Oh, I mentioned test side. Sorry, guys. Okay, it is 0.1. Test side is 10%. Better? Looks good now? Okay, I think there are a lot of things left, guys. Can we do it after break? After break is fine. All right. Okay. So we are done till the splitting part. Now next thing is we are going to do some processing before the model. Okay. We are going to do some processing. Processing will take time, guys. It will take at least 15-20 minutes. Please share the PDF file. I will share the PDF file. So guys, break is already started. I will start a timer, but you guys can go ahead. Okay. Downloads today is 11. 11/10/2025. I'm sharing everything, guys. Guys, go ahead. Break is already started. I'm not going to teach anything more. So first is I want to share logistic regression. Data is already present here. And then what else I want? Wait, guys. What else I need? I need. Guys, data set link is present in the notebook. I've already shared the link before, but it is already present there. PDF is also uploaded. You guys can check those PDF. And I'm starting a timer. You guys, please be energetic. We have a lot of things to cover. Okay. See you after break.